Alright, so the last type of curve sketching problem that we're going to tackle is one with ln, and this is going to kind of significantly impact the way the graph is drawn. So just the keys to remember with graphs involving ln is that ln of 0 is undefined, ln of negative anything is undefined, and ln of 1 is 0. So let's start with our asymptotes. Functions with ln in them always have vertical asymptotes. So if we consider our normal graph of ln, it looks something like this, right? And then we have a vertical asymptote at x equals 0. So in this scenario, we're going to set the inside of the ln equal to 0 to figure out where our vertical asymptotes are. So 12, and that is because the inside, or you can't take ln of 0, right? So if we want to find the vertical asymptote, we got to figure out where the inside equals 0. So this is going to happen at plus or minus the square root of 12. So we have a vertical asymptote at x equals negative square root of 12, and we have a vertical asymptote at x equals square root of 12. All right, so now there are not going to be any horizontal asymptotes because what's inside of the ln is a polynomial, and ln just in and of itself isn't going to have horizontal asymptotes. All right, so then we're going to want to go on to our intercepts. And so for our intercepts, we're going to start with x-intercepts, which we get by setting f of x equal to 0. So ln of 12 minus x squared equals 0. So we can add a base of e to either side to get 12 minus x squared equals 1, because e to the 0 is 1, anything to the 0 is 1. So then we can move that 1 over. 11 equals x squared, so x equals plus or minus the square root of 11. Okay, so let's list those out as points. And then for our y-intercepts, we're going to plug in a 0 everywhere we see an x. So ln of 12 minus 0 squared. So that's just going to be ln of 12. So we're going to have y-intercept at 0, comma, ln 12. So this is our 3 intercepts. So now we're going to talk about the domain. And so with ln functions, we have to exclude everywhere that the function is not defined, right? So it's not defined when inside of the ln is 0 or is a negative number. So we have to say that the inside of the ln, right? The inside of the ln has to be greater than 0. So we can do this, and then we can say plus or minus the square root of 12 has to be greater than x. So what this means is x, or square root 12, has to be greater than the absolute value of x, which means that x has to be between negative square root 12 and square root 12. So the domain of our function is going to be negative square root 12 to square root 12. All right, great. So now we got to think about the first derivative. So when we take our first derivative, we are deriving ln of 12 minus x squared. So that's going to be 12 minus x squared on the denominator and negative 2x in the numerator. So if we go ahead and we make a sign chart with that, we're going to get the critical values for our sign chart by, first of all, setting the numerator equal to 0. And that happens at x equals 0. So we have x equals 0, and that can be a max or a min, because we got it from the numerator. As opposed to if we got it from the denominator, then these are vertical asymptotes of the first derivative, so they are not eligible to be maxes, nor are they eligible to be mins. Okay, so now let's see what we get on these intervals. So to the left, you plug in a negative, so then this becomes negative. This will become a negative, so that's 3 negatives, so we get a negative. Over here, we plug in a negative. Down here will be a positive, and then so that'll be 2 negatives and 1 positive, which is a positive. Right here, that will end up being a negative, and then right here that will end up being a positive. Alright, great. So now we can say we are increasing from negative square root 12 to 0, and then again from square root 12 to infinity. And we are decreasing from negative infinity all the way up to negative square root 12, and then again from 0 to square root 12. Okay, so, and then this is going to be a max. So we got a max at x equals 0, and then increasing and decreasing. Alright, so now we got to think about our second derivative. So let's just go ahead and let's grab our first derivative. And so this is our f prime of x. Our f double prime of x is going to be a quotient rule, where our u is negative 2x, so our u prime is going to be negative 2. Our v is going to be 12 minus x squared, and our v prime is going to be negative 2x. So u prime v minus uv prime over v squared is going to equal negative 2 times 12 minus x squared minus negative 2x times negative 2x, all over 12 minus x squared squared. So that is going to be negative 24 plus 2x squared, and then that's going to be minus 4x squared. So that is going to be negative 2x squared minus 24, all divided by 12 minus x squared squared. Okay, and then I'm just going to rewrite that as negative 2x squared plus 12. Okay. Over 12 minus x squared squared. Okay. So now we got to make a sign chart of this. So, what makes this on the bottom 0? 12 minus x squared equals 0. 12 equals x squared, so x equals plus or minus square root 12. So we know we got negative square root 12, and we got square root 12. What makes this negative? Well, this can never be negative, right? Because we're looking at a positive 12 here, and anything that gets squared is going to be positive. So this can never be equal to 0. So these are going to be the only two critical points that we are going to be dealing with. So now to make the sign chart, if we plug in something on this interval, we're looking at, well, this is always going to be positive. And then we are going to end up with a negative down here. Or actually, this is always going to be positive, right? Because it gets squared. So this is always going to be a positive. And so the concavity actually isn't going to change for the entire interval. It's always going to be negative, because positive times a positive times a negative. So we are going to be concave up, never, and we are going to be concave down from negative infinity to negative square root 12, from negative square root 12 to square root 12, and then from square root 12 to infinity. And notice we are excluding those critical points. These are also going to be vertical asymptotes of the second derivative. All right, so now to graph our function. So we always start with the asymptotes. So we got a vertical asymptote at negative square root 12 and square root 12. Okay, so negative square root 12, square root 12. Great, so now let's think about our intercepts. So we got intercepts, negative square root 11 and square root 11, and 0 ln 12. Okay, so let's fill in our graph. Like this. Okay, and so now our intervals of increasing and decreasing, right, are going to be, so we're going to be decreasing. So this and this are actually outside of our domain, so they cannot impact our function. So from negative square root 12 to 0, we are increasing, and from 0 to square root 12, we are decreasing. All right, great. And then, so then that's just going to be down here because these are vertical asymptotes, and we cannot cross them. So this is going to be something like our function is going to look like. So we have no inflection points. We have one max at x equals 0. And then other than that, let's label our vertical asymptotes. X equals square root 12 and x equals negative square root 12. Other than that, we are done. That's what our graph is going to look like.